Hey guys, Stat 1150. The title of this video is Picturing Variation with Graphs. And I guess the overarching goal of what we want to do here is to see and summarize our graphs. All right, so we have data that's been collected, and we want to come up with kind of creative ways of where we can see patterns, detect patterns, because ultimately the patterns will tell us a lot of important things about the numerical summaries, which we'll get into here very shortly. Not in this video, but in an upcoming video, and we will be able to summarize these distributions. So see the patterns and summarize the patterns that we see. Now, a couple of things in this video. Number one, I want you to have access to Blackboard, because there are some data sets that I've uploaded that we're going to take these data sets and we're going to put them into R. And I'm going to show you how to use R to create distributions, summarize distributions, see and summarize again, for different types of data. Now, the two types of data that we run into, as I tried to teach you in a previous video, are quantitative numerical data. We have certain types of ways that we picture variation with that specific type of data. And we also have different types, and we call this qualitative. We have different types of pictures that we look at to see and summarize categorical and qualitative variables. So again, we have things that I'll teach you for the quantitative and numerical are called dot plots and histograms. I'm not a big fan of dot plots, but I'm going to show you show you how to create them. I'm going to show you the limitations. But there are certain situations where it actually works well for us, but not often. And again, I'll also show you histograms. For categorical and qualitative data, we use different types of pictures. We use pie charts and bar charts. So for quantitative numerical, we'll use dot plots and histograms. And for categorical and qualitative, we will use pie charts and bar charts. You really get into quite a quandary, quite a statistical dilemma if you try to use pie charts for these or dot plots for these. It gets into all sorts of crazy kind of stuff. All right, very first thing. Now, one more thing. I'm kind of getting ahead of myself. I want you to have access to Blackboard. I want you to be able to get these data sets, which I'll illustrate in this video, and R. But I also want you to have your TI 83 or 84 calculator handy too, because I'll show you ways that we can use it to put in to enter our data and create these types of these types of plots, or I'm sorry, these types of graphs. Now, the first thing is we should start out with some data. So let's say that we have someone who plays basketball. So he or she takes the number of points that they've scored, and so far they scored 11 points in one game, 12 points in 3 games, 13 points in 4 games, 14 points in 2 games, 15 points in 1 game, and 20 points in another. So guys, you can clearly see that there's been variation in the number of points that they've scored. It looks like to me that day in, day out, we can say that this person scores about 13 points per game. But we'll get into that in future videos. Right now, we just want to be able to see and summarize, create graphs that allow us to picture the variation across the points that are scored. Okay. So now, guys, this is clearly a quantitative numerical data. Okay, so what we'll want to do is we'll want to focus on dot plots and histograms. Pie charts and bar charts aren't appropriate here. We want to focus on dot plots and histograms. Now, the very first thing I would probably want to do here is to collapse my data into a frequency distribution. Well, guys, I have no idea what that dark spot right there is, but it's annoying and it won't go away, so I guess we have to live with it. But anyway, living with it, what I would first of all do is I would want to create a frequency distribution. And I would want the points possibly to go on top and then the frequency to go on the bottom. So I see that we've got an 11 and we've got a 12 and we have a 13 and we have a 14 and we have a 15 and we have a 20. And we can see that 11 occurred one time, 12 occurred 3 times, 13 occurred 4 times, 14 occurred twice, 15 occurred once, and 20 occurred once. Now, you're probably sitting there thinking, well, I thought stats was hard. That's it's not hard yet, is it? So enjoy it while it lasts. Now, gang, if I was going to create a dot plot for this data, so hopefully you've taken this down in your notes and you have the data in front of you. It would work something like this. Dot plots typically have just a horizontal axis, and what we'll want to do is we'll want to put the observations from the smallest up to the highest. And you notice that we don't have any 16, 17, 18s, and 19s, but guys, we still need to put that in our axis so we can allow for the total spread. Again, seeing the distribution, summarizing it, picturing variation. Well, if we just go 11, 12, 13, 14, 15, and then go 20, you know, that's not going to make any sense, because that distance between 15 and 20 is the same as between 14 and 15. It just doesn't make good sense. But anyway, a dot plot works like this. We put one dot for every observation that we have above the score. So we had 111. We had 3 12s. We had 4 13s. We had 2 14s. We had 115. We haven't fun yet, and we had 120. Now, guys, we're going to find out later that this this huge separation right here creates this 20. You know, it's kind of an outlying observation. We call it an outlier. But we'll get into box plots here within the next couple of videos, and we'll talk about those more. But what we can see is if we kind of smooth out this distribution, we can see that we have a tail in this distribution that goes out to the right. Now, what that does is it allows us to better summarize. So again, see and summarize. Think this is important? Well, when I repeat things a billion times in a video, it means it's important. See and summarize. Well, we now see the distribution. Now we want to summarize it. Well, guys, for the sake of this class, we want to summarize. Let me make sure I stay exactly with the terminology that the textbook uses. Yeah. So the textbook here calls this either a right skewed, a left skewed, symmetric, or bell-shaped. Okay, so what we do, and these are for quantitative data only. It's also important when I capitalize it. quantitative only. When I repeat myself a billion times and I capitalize it, it's super, super, super important. But what we want to do is we want to look at these dot plots or histograms coming up. And apparently my wife's texts are coming up on the screen, so just ignore that, please. A dot plot or a histogram for quantitative, we're going to decide which one of these describes our distribution. Now, right tail says that we have a distribution like this and the tail goes to the right. Left tail would be if we just took this and flipped it. So if we had the same thing over here, but we had the tail coming over here to the left, then that would be left-tailed or left-skewed. Symmetric, if I could come in and magically get rid of that point out there, then we would have a symmetric distribution which is also bell-shaped.